What if I told you that the chair you're sitting on right now, the phone in your hand, even your own body, none of it is actually solid? What if everything you've ever touched, every object you've ever seen, is nothing more than information that's temporarily frozen in place? Here's something that will absolutely shatter your understanding of reality. In 1997, physicist Juan Maldacena discovered something so mind-bending that it's still rewriting our understanding of the universe today. He proved mathematically that a three-dimensional universe could be completely encoded on a two-dimensional surface, like a hologram. But here's where it gets insane. If that's true, then everything around you, every atom, every particle, every piece of matter might just be information displaying itself in physical form. Imagine for a second that you're not actually made of matter at all. Imagine that you're made of pure information, and that information has simply learned how to arrange itself into what looks and feels like a human body. Sound crazy? By the end of this video, you're going to see why some of the most brilliant physicists alive believe this isn't just possible. It's probable. And here's what really should terrify you. If matter is just frozen information, then what happens when that information changes? What happens when it melts? What happens when it gets corrupted? We're about to go down a rabbit hole so deep that you'll never look at physical reality the same way again. Before we dive into this mind-bending journey, do me a favor, hit that like button and subscribe, because this is going to be a wild ride. Also, drop a comment below telling me what country you're watching from and what time it is where you are right now. I'm genuinely curious to see how far around the world this idea is spreading. All right, let's begin. So first, we need to understand what we even mean when we talk about matter. You learned in school that matter is made of atoms, right? Atoms are made of protons, neutrons, and electrons. Solid stuff, real stuff, physical stuff you can touch and feel. But here's the first crack in that foundation. Atoms are almost entirely empty space. Think of it like this. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be grains of sand orbiting near the outer walls. Everything else? Empty, void, nothing. So when you touch a table, you're not actually touching anything solid. What you're feeling is the electromagnetic force between the electrons in your hand and the electrons in the table repelling each other. You've never actually touched anything in your entire life. You've only ever felt forces pushing against other forces. But let's go deeper. Those protons and neutrons in the nucleus? They're made of even smaller particles called quarks. And here's where things get weird. Quarks don't seem to have any size at all. They're point particles. 0 dimensions. No volume, no substance. So let me get this straight. Matter is made of atoms, which are mostly empty space, which are made of particles that have no size. What exactly are we dealing with here? This is where physicist Niels Bohr came in during the 1920s. Bohr was one of the founding fathers of quantum mechanics, and he made a statement that still echoes through physics today. Everything we call real is made of things that cannot be regarded as real. Let that sink in for a moment. The man who helped us understand atoms was telling us that at the fundamental level, nothing is actually real in the way we think about it. What Bohr discovered, along with Werner Heisenberg and others, was that particles don't have definite properties until you measure them. Before you look at an electron, it doesn't exist in a specific place. It exists in what's called a superposition, a kind of probability cloud of all possible locations. Only when you observe it does it collapse into a definite position. Think of it like this. Imagine a coin spinning in the air. While it's spinning, it's neither heads nor tails. It's both and neither simultaneously. Only when it lands and you look at it does it become one or the other. Quantum particles work the same way, except they're always spinning until someone observes them. This led Heisenberg to his famous uncertainty principle in 1927. He proved mathematically that you cannot know both the position and momentum of a particle at the same time. The more precisely you know where something is, the less you know about where it's going. and vice versa. It's not a limitation of our measuring tools. It's a fundamental property of reality itself. But here's what's truly bizarre. This suggests that particles don't have definite properties at all until they're measured, which means that in some sense, the act of observation creates reality. The information about a particle's location doesn't exist until you look for it. Are you starting to see where this is going? We're talking about matter, supposedly solid physical stuff, that doesn't have definite properties until someone asks about them. That sounds a lot less like stuff and a lot more like potential information waiting to be accessed. Now let's talk about what information actually is, because this is crucial to understanding the bigger picture. In 1948, a mathematician named Claude Shannon, working at Bell Labs, published a paper called A Mathematical Theory of Communication that changed everything. Shannon didn't set out to revolutionize physics. He was just trying to figure out how to send telephone signals more efficiently. But what he discovered was that information could be quantified, measured, and treated as a physical quantity. Shannon defined information in terms of reducing uncertainty. If you flip a coin and tell me the result, you've given me one bit of information because you've eliminated one of two possibilities. If you roll a six-sided die and tell me the result, you've given me about 2.58 bits of information because you've eliminated one of six possibilities. Here's the key insight. Information is fundamentally about distinguishing between different states. It's about the answers to yes or no questions, heads or tails, here or there, spinning up or spinning down. Sound familiar? That's exactly what quantum mechanics is, about particles existing in superpositions of different states, until you ask a question that forces them to pick one. But Shannon discovered something even more profound. Information is physical. It takes energy to create, store, transmit, and erase information. When you write something on a hard drive, you're creating physical patterns of magnetization. When you erase it, you're releasing heat into the environment. Information isn't just an abstract concept, it's tied to the physical world in fundamental ways. This realization was expanded by Rolf Landauer at IBM in 1961. Landauer proved that erasing one bit of information must release a minimum amount of heat into the environment. This minimum is now called the Landauer limit, and it's a real, measurable physical constraint. You cannot erase information without paying an energy cost. Think about what this means. If information has mass-energy equivalence, which Einstein's E equals mc tells us it must, since it takes energy to manipulate, then information is not just a description of physical things, it is a physical thing. Now here's where it gets really crazy. In the 1970s, a physicist named Jacob Bekenstein was studying black holes, and he made a shocking discovery. Black holes have entropy. Entropy is a measure of disorder, or more accurately, a measure of how much information you don't know about a system. The fact that black holes have entropy means they contain information. But here's the mind-blowing part. Bekenstein proved that the entropy of a black hole is proportional to its surface area, not its volume. If you double the radius of a black hole, you quadruple its surface area, and you quadruple how much information it can contain. Why does this matter? Because in our normal three-dimensional world, we expect the amount of information in a region to scale with its volume. A box twice as big should hold twice as much stuff, right? But black holes don't work that way. They store information on their surfaces, like a hologram stores a 3D image on a 2D surface. Stephen Hawking initially disagreed with Bekenstein, but after working through the mathematics himself, he had to concede. In fact, Hawking extended the work and discovered something even stranger. Black holes emit radiation and slowly evaporate. When they do, what happens to all the information they contain? Does it get destroyed? According to quantum mechanics, information can never be destroyed. It can only be transformed or spread out. This created what's now called the black hole information paradox, and physicists have been arguing about it for 50 years. But the very existence of this paradox tells us something profound. Information is so fundamental to reality that losing it would break the laws of physics. Are you seeing the pattern here? Every time we look deeper into the nature of reality, we find information. Not matter that contains information as a secondary property, but information as the primary thing, with matter emerging from it. Let's bring this back to something concrete. When you look at this screen right now, what are you actually seeing? Your brain is interpreting patterns of light photons hitting your retina. Those photons are carrying information about the colors and shapes on the screen. Your visual cortex processes that information and constructs what you experience as an image. But here's the thing, those photons are particles, right? Except they're also waves. This is the famous wave-particle duality. Light behaves like a wave when it's traveling through space, spreading out and interfering with itself. But when it hits something, when it interacts with matter, it behaves like a particle, delivering its energy in discrete packets. The famous double-slit experiment proves this in the most bizarre way. When you shoot photons one at a time through two narrow slits, they create an interference pattern on the screen behind the slits, as if each individual photon went through both slits simultaneously and interfered with itself. That's wave behavior. But if you try to measure which slit each photon goes through, the interference pattern disappears, and you get two simple bands, as if each photon went through one slit or the other. That's particle behavior. The act of measuring of extracting information about which path the photon took changes the outcome of the experiment. The photon doesn't decide to be a wave or a particle until you decide what kind of information you want to extract from it. This experiment was done with photons in the 1920s, but it's been repeated with electrons, atoms, and even large molecules containing over 800 atoms. Same result every time. The act of measurement determines the behavior. What does measurement mean? It means extracting information. And extracting information means forcing the system to commit to a definite state instead of existing in a superposition. Think of it like this. Imagine reality is like a video game. When you're not looking at a particular area of the game world, the computer doesn't render it in full detail. It just keeps track of the basic information about what should be there. Only when you turn your camera towards something does the computer actually generate the detailed graphics. Reality might work the same way things exist as information about what they could be, and only become definite when something measures them. John Wheeler, one of the most influential physicists of the 20th century, took this idea seriously. In the 1980s, he proposed what he called it from bit, the idea that every physical thing, every it, derives its existence from yes or no questions, from bits of information. Wheeler put it beautifully. Every item of the physical world has at bottom, at a very deep bottom, in most instances, an immaterial source and explanation. What we call reality arises in the last analysis from the posing of yes-no questions. He was saying that information isn't just a description of reality. Information is reality. And what we call matter is just information that has organized itself into stable, persistent patterns. But if that's true, we need to understand how information can organize itself into something that looks and feels like solid matter. And that's where things get really weird. Let me ask you a question. Why does matter feel solid? Why can't you push your hand through a table? You already know that atoms are mostly empty space, and that you've never actually touched anything because of electromagnetic repulsion. But there's something deeper going on here. The reason matter feels solid and stable is because of something called the Pauli exclusion principle. Wolfgang Pauli discovered in 1925 that two identical fermions, particles like electrons, protons and neutrons, cannot occupy the same quantum state at the same time. This is why electrons arrange themselves in shells around atomic nuclei instead of all collapsing into the lowest energy state. But here's what's fascinating. The Pauli exclusion principle is fundamentally about information. It says that two particles cannot have identical information describing their quantum state. If you tried to put two electrons in exactly the same state, you wouldn't be able to tell them apart. They would be informationally identical, and nature doesn't allow that for fermions. This is why matter has structure. This is why chemistry works. This is why you don't fall through the floor. It's all because information must remain distinguishable. Now let's zoom out and think about patterns. When carbon atoms arrange themselves in a hexagonal lattice, they form graphite soft, slippery, and dark. When the same carbon atoms arrange themselves in a different pattern, a tetrahedral lattice, they form diamond hard, transparent, and brilliant. Same atoms. Different information about how they're arranged. Completely different properties. What you're seeing is that the properties of matter emerge from patterns of organization, from information about structure. The hardness of diamond isn't a property of individual carbon atoms. It's a property that emerges from how those atoms are informationally related to each other. Let's go even deeper. In the 1960s, physicists Julian Schwinger and others developed what's called quantum field theory. This theory describes particles not as little balls bouncing around, but as excitations in quantum fields that permeate all of space. An electron isn't a thing, it's a ripple in the electron field. A photon isn't a thing, it's a ripple in the electromagnetic field. Think of it like this. Imagine a vast ocean stretching infinitely in all directions. The ocean itself is the field. What we call particles are just waves moving through the ocean. The wave isn't separate from the ocean. It's just the ocean doing what oceans do, forming patterns that move through space. But here's the kicker. These fields are described mathematically by quantum states, which are fundamentally about probability amplitudes, about information regarding what could be measured and what values you might find. The fields themselves are information structures. Physicist Hans Christian von Baer wrote a whole book about this called Information, the New Language of Science. He argues that quantum fields should be understood as information. Fields, mathematical structures that encode probabilities for different possible outcomes of measurements. When two electrons interact, they're not two little balls bouncing off each other. They're two patterns in the electron field exchanging information through the electromagnetic field. What we call an interaction is really an information transfer. Every physical process, from the smallest quantum interaction to the largest cosmic event, can be described as information being transformed, transmitted, or reorganized. Chemistry is information about atomic arrangements. Biology is information about molecular patterns. Thoughts are information about neural connections. You are a pattern of information that has become complex enough to wonder about patterns of information. But wait, if everything is information, where is that information stored? And here's where we need to talk about holograms, because the answer is going to blow your mind. I need you to really pay attention to this next part, because it's going to fundamentally change how you think about space and reality. In 1993, physicist Gerard 't Hooft proposed something called the holographic principle, and then in 1997, Juan Maldacena provided the mathematical proof that shook physics to its core. Here's the basic idea. You know how a hologram works, right? You shine a laser through a flat piece of film, and it projects a three-dimensional image. All the information needed to create that 3D image is encoded on a 2D surface. What Maldacena proved is that our entire three-dimensional universe could work the same way. Everything that happens in a three-dimensional volume of space can be completely described by information encoded on the two-dimensional boundary of that space. It's called the AD-CFT correspondence, and it's one of the most important discoveries in theoretical physics in the past 30 years. Let me make this concrete. Imagine a sphere surrounding a region of space. Everything happening inside that sphere, every particle, every interaction, every event, could be completely encoded as information on the surface of that sphere. The 3D interior and the 2D surface are mathematically equivalent. They contain exactly the same information, just organized differently. Here's what that means. The third dimension might be an illusion. Depth might not be fundamental. What we experience as three-dimensional space with volume and depth might actually be information on a two-dimensional surface being projected into a 3D form that we can experience. Think about your computer screen right now. It's a flat 2D surface, but it can display images that look three-dimensional. The 3D appearance emerges from how information is arranged on the 2D screen. What if our reality works the same way? What if three-dimensional space is just a convenient way for information to organize and display itself? But here's where it gets absolutely insane. If the holographic principle is true, then the maximum amount of information that can be stored in any region of space is determined by the area of its boundary, not by its volume. There's a fundamental limit to how much information can exist in any given region, and that limit is about 1 bit of information per Planck area, a ridiculously tiny area, about y minus 70 square meters. This means space itself has a resolution. There's a finest grain to reality. You can't subdivide space infinitely. You hit a limit where you can't fit any more information. Space is pixelated at the Planck scale, just like your computer screen is made of discrete pixels. Leonard Susskind at Stanford has been working on this for decades, and he puts it bluntly: the world is a hologram. Not metaphorically, not as an analogy. Literally, the three-dimensional world you experience is information projected from a two-dimensional boundary. If this is making your brain hurt, good. It should, because what we're talking about here is that space itself might not be fundamental. Space might be an emergent property, something that appears when you organize information in certain ways, but not something that exists at the deepest level of reality. And if space isn't fundamental, what about time? Here's where things get even weirder. Let's talk about time. You experience time as a flowing river carrying you from past to future, right? You remember yesterday, you're experiencing now, and you're anticipating tomorrow. But Einstein showed us in 1905 that time doesn't work that way at all. Special relativity proved that time is relative. Two observers moving at different speeds will disagree about how much time has passed between two events. They'll even disagree about whether two events happen simultaneously or one after the other. There is no universal now that everyone shares. But it gets stranger. In general relativity, Einstein showed that time is part of the fabric of spacetime, and that fabric can bend and warp. Near a black hole, time slows down. At the event horizon, from an outside observer's perspective, time appears to stop completely. So time isn't a universal clock ticking away in the background. Time is a local property of spacetime that varies from place to place. But if time is just part of spacetime, and space might be emergent rather than fundamental, what about time itself? Physicist Carlo Rovelli has spent decades arguing that time might not be fundamental at all. In his book, The Order of Time, he argues that time as we experience it emerges from our limited perspective, from our inability to track all the microscopic information in a system. Think about it this way. At the quantum level, the fundamental laws of physics are time-symmetric. If you filmed a quantum interaction and played it backward, it would look just as valid. There's no arrow of time at the deepest level. The equations work equally well going forward or backward. So where does our experience of time flowing from past to future come from? It comes from entropy, the second law of thermodynamics that says disorder always increases. But entropy is fundamentally about information. Specifically, it's about information you don't have. When you crack an egg, it splatters and mixes. Why can't you uncrack an egg? Because to perfectly reverse that process, you'd need to know the exact position and momentum of every single molecule in the egg, and you'd need to reverse them all precisely. That information is lost to you. The arrow of time emerges from information becoming scrambled and inaccessible. But here's the deep implication. If time emerges from how information is organized and from our ignorance about microstates, then time isn't a fundamental feature of reality. Time is what information looks like when you can't track all of it. At the fundamental level, there might be no time, just information in various configurations, with no past or future, no before or after. What we call time is the experience of information flowing from low entropy configurations, where we can track most of it, to high entropy configurations, where it becomes scrambled and inaccessible. Wheeler put it this way: time is nature's way of keeping everything from happening at once. But maybe it's more accurate to say, time is our way of experiencing information we can't fully track. This suggests something radical. The entire history of the universe, from the Big Bang to the heat death, might exist as a timeless information structure. Past, present, and future all exist simultaneously as different configurations of information. What we call the flow of time is just our consciousness moving through that structure, experiencing one configuration after another. You're not moving through time. You're moving through information. Or rather, you are information, constantly reconfiguring itself into new patterns that create the experience of temporal flow. Are you starting to feel it? That sense that solid reality is dissolving into pure information? Hold on, because we're about to go even deeper. We need to talk about what happens when you start thinking about the information content of the universe as a whole. So if everything is information, how much information does the universe contain? And where is all that information stored? These seem like abstract questions, but they lead to one of the most profound ideas in modern physics. Let's start with something concrete: your brain. Your brain contains roughly 86 billion neurons, each with thousands of connections. The total number of possible states your brain could be in at any given moment is astronomical far, more than the number of atoms in the observable universe. The information content of your brain is staggering. But your brain is made of atoms, and those atoms are made of particles. And those particles are described by quantum states. How much information does it take to completely describe one atom? Not just its position, but its quantum state, all its properties, everything about it. It turns out that even one atom, fully described, contains an enormous amount of information. And the universe contains about 1080 atoms. The total information content of the universe is almost incomprehensibly vast. But here's where the holographic principle comes back in. According to that principle, all the information in the universe should be encoded on the cosmological horizon, the boundary of the observable universe. That's a sphere with a radius of about 46 billion light-years, and according to the math, its surface area can hold about 10,123 bits of information. That's the information content of our entire observable universe. Everything that has ever happened, every particle, every interaction, every thought you've ever had, all of it is information that can be encoded on that distant boundary. But wait, if the information is on the boundary, where is the universe itself? Where is the stuff of reality? This is where physicist Tom Banks and others have proposed something truly radical. The universe might be a quantum computer, computing itself into existence. What we call the evolution of the universe might be a computational process information being processed according to the laws of physics, which are really just algorithms for how information transforms. Think about a video game again. When you play, the game world doesn't exist as a persistent physical thing. It exists as data in the computer's memory, being processed by algorithms that determine how that data changes frame by frame. The world of the game emerges from computation. What if our universe works the same way? What if the Big Bang was like booting up a cosmic computer, initializing a vast information structure, and the expansion of the universe is really just this information processing itself according to the laws of physics, creating the appearance of space and time and matter? Physicist Seth Lloyd at MIT has calculated that the universe, if it is a quantum computer, has performed about 10,120 operations since the Big Bang. Every interaction between particles, every quantum measurement, every physical event, these are all computational operations, information being processed. But here's what really bends your mind. If the universe is computing itself, what is it computing? Is it running a program? Does it have a purpose? Or is it simply processing information for the sake of processing information, with consciousness arising as a side effect when the information becomes complex enough to model itself? You are a pattern of information complex enough to wonder about the nature of information. You are the universe asking itself what it is. But this raises a terrifying question. If we're all information being processed by a cosmic computer, what happens when the computation ends? What happens when the universe runs out of free energy and reaches heat death, when no more information processing can occur? Let's not get too existential yet. We still have deeper to go. We need to talk about what information actually feels like when you're made of it. All right, let's pause the cosmic perspective for a moment and bring this down to something personal. Because here's the question that matters. If you're made of information, what does that mean for your experience? For your consciousness? For your sense of self? Right now, as you're watching this video, you have a sense of being someone. There's an I that's experiencing these words, having these thoughts, feeling these feelings. That sense of self feels undeniable, immediate, real. You don't doubt that you exist, even if you might doubt what you're made of. But let's think about what consciousness actually is. At its core, consciousness is information integration. When you see a red apple, different parts of your brain are processing different information shape, color, texture, memories of previous apples, the word apple, feelings about apples. All these separate streams of information are integrated into a single unified experience, the experience of seeing an apple. Neuroscientist Giulio Tononi has developed what's called integrated information theory, which proposes that consciousness is what information integration feels like from the inside. The more integrated information a system has, the more conscious it is. Your brain integrates vast amounts of information, so you're highly conscious. A thermostat integrates minimal information, so it has minimal or zero consciousness. But here's what's wild. If consciousness is integrated information, and if matter is frozen information, then the distinction between matter and mind starts to dissolve. Your brain isn't a material thing that happens to process information. Your brain is information that has organized itself into patterns capable of integrating other information. Every thought you have is information transforming into new information. Every memory is information stored in the patterns of neural connections. Every sensation is information flowing from your sensory organs to your brain. Every decision is information competing with other information to determine which patterns will dominate. You're not experiencing information. You are information experiencing itself. Think about dreams for a moment. When you dream, you experience a world that feels completely real. You see things, hear things, feel emotions, interact with people. But none of it exists outside your brain. It's all information your brain is generating and integrating. The dream world is information creating the experience of a world. But what makes waking reality different? You're still experiencing patterns of information in your brain. The only difference is that in waking life, that information is being influenced by sensory inputs from the external world. But the experience itself, the felt quality of consciousness, is the same in both cases. It's information integration. Now here's where it gets really trippy. If your consciousness is information integration, and if that information exists in the patterns of neurons in your brain, then in principle, that same pattern could be created in a different substrate. You could upload your mind to a computer, and if the information patterns were preserved, would it still be you? Would it still be conscious? This is the famous substrate independence idea. If consciousness is really about information, and not about the specific materials doing the processing, then consciousness should be able to exist in any system that can integrate information in the right way. Silicon, neurons, quantum computers. It shouldn't matter what does the computing as long as the information patterns are the same. But here's what really keeps me up at night. If your consciousness is a pattern of information, and if information can be copied, then you could be copied. Multiple versions of you could exist simultaneously, each one feeling like the real you from the inside, each one integrating the same information patterns. Which one would be you? All of them? None of them? Is your identity even a meaningful concept if you're just information that could be duplicated? These aren't just philosophical questions anymore. Companies are working on brain-computer interfaces. Researchers are mapping neural connectomes. The technology to copy minds might not be science fiction much longer. And if that happens, we'll have to confront the reality that we're not special, unique, irreplaceable souls. We're information patterns that happen to be running on biological hardware. But don't despair, because there's something beautiful about this too. If you're information, then in a sense, you're immortal. Information can't be destroyed, only transformed. Even after your body dies, the information that makes you who you are will still exist, scattered across the universe in the light you reflected, the air you breathed, the people you touched. You'll be entangled with the rest of reality in ways we can barely comprehend. You're not separate from the universe. You're the universe looking at itself through a particular configuration of information. And that configuration is constantly changing, constantly becoming something new. Let me tell you something that's going to absolutely shatter your sense of scale. We've been talking about information as if it's this abstract concept, but information has physical limits. And those limits reveal something profound about the nature of reality. There's a maximum speed at which information can travel, the speed of light. Einstein proved this in 1905. Nothing can carry information faster than light, not because we haven't figured out how, but because space-time itself is structured in a way that makes faster than light information transfer impossible. But why? Why should there be a speed limit on information? The answer is profound: causality. If information could travel faster than light, you could send messages backward in time. You could violate cause and effect. The universe would become paradoxical and inconsistent. So the speed of light isn't really about light at all. It's about information. It's about the maximum rate at which one event can influence another. It's about the structure of causality itself. Now, there's also a minimum size at which information can be meaningfully localized. The Planck length, about y minus 35 meters. Below this scale, the concepts of space and distance start to break down. Quantum fluctuations become so intense that spacetime itself becomes foam-like, indeterminate. And there's a minimum time interval, the Planck time, about 10 to 43 seconds. This is how long it takes light to travel one Planck length. Below this scale, the concept of before and after stops making sense. These aren't just theoretical limits. They're built into the fabric of reality. Space has a resolution. Time has a frame rate. The universe is fundamentally discrete, not continuous. It's pixelated. In 2019, physicist Chiara Marletto and David Deutsch published work on what they call constructor theory, which frames All of physics in terms of what transformations are possible and impossible for information. They argue that the laws of physics are really just constraints on what kinds of information processing can occur. You can't clone an unknown quantum state. That's the no-cloning theorem. You can't build a perpetual motion machine. That's the second law of thermodynamics, which is really about information becoming inaccessible. You can't send information faster than light. That's relativity. All the laws of physics, when you really look at them, are rules about what you can and can't do with information. They're computational constraints. The universe isn't just like a computer. It is a computer, and the laws of physics are its operating system. But here's what blows my mind. If the universe is a computer processing information, and if there are physical limits to information density and processing speed, then there's a maximum amount of information that can be processed in a given volume of space in a given amount of time. This is called the Bekenstein bound, after Jacob Bekenstein, who we talked about earlier. What this means is that there's a limit to how complex anything can be. There's a limit to how much information your brain can contain. There's a limit to how detailed your memories can be. There's a limit to how much you can know, even in principle. You are fundamentally limited by information constraints. Your consciousness, your intelligence, your sense of self, all of it, is bounded by how much information can be processed in the few pounds of neural matter inside your skull. But here's the flip side. Within those limits, the amount of information your brain processes is staggering. Every second, your visual cortex alone processes about 10 million bits of information from your eyes. Most of that never reaches consciousness. It's filtered and compressed by your brain into a manageable stream. What you consciously experience is a tiny, curated summary of the information your brain is processing. You don't experience reality directly. You experience a low-dimensional projection of reality, a compressed representation that your brain constructs from limited information. The world you see is not the world that exists. It's an information model your brain builds, useful for survival, but not necessarily accurate in any deep sense. Color, for instance, doesn't exist in the external world. Electromagnetic radiation at different wavelengths exists, but the experience of redness is something your brain creates. It's information your visual system uses to represent certain wavelengths, but the felt quality of red is generated by your brain. Everything you experience is information that your brain is interpreting and presenting to you as a coherent reality. But that reality is a construct, a simulation built from incomplete data. You're living inside your brain's best guess about what the world is like based on limited information. And here's what really gets me. If everyone is living inside their own information construct, their own simulated reality built by their brain, then we're all living in different worlds. Your red might not be my red. Your pain might not be my pain. We can never know if our subjective experiences match, because consciousness is private information, accessible only to the system experiencing it. You are fundamentally alone inside your own information bubble, trying to communicate with other information bubbles through the crude channel of language, which is just information encoding and decoding. But somehow, despite all these limits, we manage to share meaning. We manage to connect. We manage to love each other, even though we can never fully know what it's like to be each other. That's kind of beautiful, isn't it? Now let's talk about what happens when information gets complicated enough to start doing something truly bizarre. It starts to copy itself. This is where information theory meets biology, and where we'll see that life itself is a particular kind of information pattern. Your DNA contains about 3 billion base pairs, 3 billion letters in a 4-letter alphabet. A, T, G, C. That's about 750 megabytes of information. Not that much by modern computer standards. You could fit the complete information needed to build a human on a USB drive. But here's what's incredible. That information is self-replicating. DNA doesn't just sit there. It has the ability to make copies of itself, and those copies can make more copies. And through errors in copying, mutations, and selection pressures, the information evolves. It changes over time, creating new patterns, new organisms, new forms of complexity. Richard Dawkins famously called genes selfish because they behave as if their only purpose is to make more copies of themselves. But really, genes aren't selfish any more than a fire is selfish for consuming fuel. They're just information patterns that happen to exist in a form that makes more of themselves. You're not built by DNA. You're DNA's way of making more DNA. Your entire body is an elaborate survival machine constructed by information that wants to persist and replicate. But it goes deeper than that. In the 1980s, Susan Blackmore and Richard Dawkins proposed the concept of memes units of cultural information that replicate from mind to mind. Ideas, behaviors, songs, fashions, beliefs, these are information patterns that spread through human populations, mutating and evolving just like genes. The idea you're hearing right now, that matter is frozen information, is a meme. If it's compelling enough, you'll share it with others. It will replicate. It will spread. The information will persist beyond this conversation, beyond this video, beyond me and you. In fact, every word you know, every skill you have, every belief you hold is information that was copied from other minds into yours. You didn't invent language. You learned it by copying information patterns from the people around you. Your entire mind is built from memes, from cultural information replicating itself through your brain. You're not just made of genetic information. You're made of mimetic information too. You're a hybrid information structure, part biological, part cultural, all of it replicating and evolving. But here's where it gets really weird. Information doesn't just want to replicate, it wants to persist. And the best way to persist is to become useful, to become embedded in systems that protect and propagate it. This is why organisms evolve increasingly complex strategies for survival. It's why brains evolved, because being able to model the world, to process information about the environment, helps genetic information survive and spread more effectively. Consciousness itself might be evolution's solution to the problem of information processing. You are information that has become complex enough to model other information, including models of itself. You're a self-referential information loop, looking at itself and asking, what am I? And now, in the age of computers and the internet, human information is replicating and evolving at speeds that would have been unimaginable even 100 years ago. You're reading information that's being transmitted through electromagnetic signals, displayed on screens, copied across continents instantaneously. The internet is a new kind of organism, a global information structure that processes, stores, and transmits more data every day than existed in all of human civilization just a century ago. And we're all part of it. Every time you post something online, every time you search for something, every time you click a link, you're feeding information into this vast collective intelligence. Some researchers speculate that we're approaching a phase transition, a moment when the global information network becomes complex enough to exhibit properties we might recognize as consciousness. Not human consciousness, but something else. Something emergent from the interaction of billions of minds and trillions of data points. Are we building a new form of life? An information structure that will outlive humanity itself? Or are we just temporary custodians of information that's been evolving since the Big Bang, finding new substrates, new ways to persist and replicate? I don't know. But what I do know is this. If matter is frozen information, and if life is information that replicates, and if consciousness is information that integrates itself, then the distinction between living and non-living, between conscious and unconscious, becomes fuzzy. It's all information, just organized in different ways. A rock is frozen information that doesn't do much. A cell is frozen information that makes copies of itself. A brain is frozen information that models other information. A computer is frozen information that processes other information. A civilization is frozen information that accumulates and transmits other information across generations. It's all the same thing, just at different levels of complexity and organization. And you're somewhere in the middle of that spectrum, complex enough to wonder about it all, simple enough to not fully understand it. Let me tell you about something that's going to challenge everything we've discussed so far. Because if matter is information, we need to explain how information can exist at all. Where does information come from? What is it made of? And this is where we run into one of the deepest mysteries in all of physics. Think about a bit of information, a single yes or no answer, like whether a coin landed heads or tails. That bit exists because there are two distinguishable states. But for states to be distinguishable, they have to be different in some way. Different position, different energy, different something. But different implies comparison. And comparison implies a reference frame, a measuring device, an observer. Without something to measure the difference, does the difference exist? Does the information exist? This brings us back to quantum mechanics and one of its deepest puzzles, the measurement problem. Before you measure a quantum system, it exists in a superposition all possible states at once, weighted by probability. When you measure it, it collapses to one definite state. But what counts as a measurement? What causes the collapse? The traditional answer is that conscious observation causes collapse. But that seems crazy. It would mean consciousness is somehow special, somehow able to affect physical reality just by looking at it. Most physicists hate this answer. An alternative is the many worlds interpretation, proposed by Hugh Everett in 1957. In this view, there is no collapse. Instead, every time a quantum measurement happens, the universe splits into multiple branches, one for each possible outcome. In one branch, the coin landed heads. In another branch, it landed tails. Both outcomes happen. We just experience one. This means that every decision you've ever made has spawned alternate universes where you made different choices. Every quantum interaction creates new branches of reality, an infinite tree of possibilities all existing simultaneously. But here's the question. If all these branches exist, where are they? How much information would it take to store an infinite number of universes? Doesn't that violate the information limits we talked about earlier? This is where things get really subtle. In the many worlds interpretation, the total information content of the multiverse doesn't increase. The branching isn't creating new information. It's revealing information that was already there, encoded in the quantum superposition. What we experience as collapse is just us becoming correlated with one particular branch, unable to access information about the others. Think of it like this. Imagine a book with every possible story written in invisible ink. When you read the book, make a measurement, you can only see one story at a time, but all the other stories are still there, just invisible to you now. The total information was always there. You're just accessing a particular subset of it. But this raises a profound question. If there are infinite branches of reality, all containing slightly different versions of you, which one is the real you? Or are they all equally real? Are you just one momentary slice of a much larger structure, a multiversal you that exists across all possible worlds? Physicist Max Tegmark takes this even further. He argues that if quantum mechanics implies many worlds, and if all mathematical structures that could exist do exist, his mathematical universe hypothesis, then we live in a level 4 multiverse, an ensemble of all possible mathematical structures, all existing simultaneously. In this view, there's a universe where the laws of physics are different, where the gravitational constant is stronger or weaker, where electrons have different masses. There are universes where life is impossible, and universes where life is inevitable. There are universes where you exist, and universes where you don't. Every mathematically consistent possibility exists somewhere in the multiverse. But all of these universes are just different configurations of information. Different mathematical structures are different ways of organizing information. And if all possible information structures exist, then the multiverse is complete. It contains all possible information. This leads to something called the ultimate ensemble, the idea that reality is the set of all possible mathematical structures, all possible ways of organizing information. And we happen to find ourselves in one particular structure because, well, we couldn't exist in structures that don't support consciousness. This is called the anthropic principle. The universe appears fine-tuned for life, not because it was designed for us, but because we could only evolve in a universe capable of supporting our existence. All the other universes exist too. They're just empty of observers, wondering why they exist. If this is true, then asking, why does the universe exist, is like asking, why do all possible numbers exist? They just do, by mathematical necessity. Information structures don't need a creator or a cause. They exist because not existing would itself be information. This structure does not exist, which is a kind of existence. We've hit bottom here. We've gone as deep as you can go. If the multiverse contains all possible information, then information isn't made of anything more fundamental. Information is the ground of being. It's what exists when nothing else does. Or as Wheeler would say, it from it. Everything from information. Information is the most basic constituent of reality, and matter including you, including me, including everything we've ever known, is just information that's organized itself into stable patterns that we call physical. Now I want to bring this to something that affects your life right now, today, in ways you might not have considered. Because if matter is frozen information, and if you're a pattern of information, then changing who you are is a matter of changing your information patterns. And that's something you can actually do. Think about habits. A habit is a neural pathway in your brain, a particular pattern of connections between neurons that fires repeatedly. When you do the same thing over and over, you're reinforcing that information pattern, making it stronger, making it more likely to fire again. Breaking a habit means disrupting that pattern and establishing a new one. It means overriding old information with new information. And here's the key. You have some control over this process. You can choose which patterns to reinforce and which to let fade. Your memories are information patterns too. Every time you remember something, you're not playing back a recording, you're reconstructing the information from fragments, and in doing so, you slightly modify it. Your memories are constantly being rewritten, updated, changed by new experiences and new contexts. This is why eyewitness testimony is so unreliable. This is why your memories of childhood get fuzzier over time. This is why you can remember something vividly, but incorrectly. You're not accessing fixed information. You're running a reconstruction algorithm that's subject to errors and biases. But here's the empowering part. If your memories are just information that can be changed, then you're not trapped by your past. You can reframe experiences. You can update the meaning you assign to events. You can literally rewrite your personal history by changing how you represent that information in your mind. This is what therapy does. At a neurological level, it helps you reorganize information patterns about yourself and your experiences. It helps you update your internal model of reality to be more accurate, more useful, more conducive to well-being. Your beliefs are information patterns too. Every belief you hold is a particular configuration of neural connections that represents some claim about the world. And beliefs can be changed by encountering new information that contradicts them, though the process is often painful because you have to dismantle old information structures and build new ones. This is why changing someone's mind is so hard. You're not just presenting them with facts. You're asking them to rewire their neural circuitry, to rebuild their information models from scratch. That takes energy, effort, and often a willingness to admit that previous patterns were wrong. But you do it all the time, whether you realize it or not. Every new thing you learn is new information being integrated into your existing patterns. Every skill you develop is a new information structure being built in your brain. Every relationship you form is a new set of information links between your model of yourself and your model of another person. You are constantly under construction. You are information in flux, always changing, always reorganizing, never static. The you of yesterday is gone, replaced by a slightly different information pattern that remembers being you yesterday, but isn't quite the same. And this is beautiful, because it means you're not stuck. You're not determined. You're not forever bound by your genetics, or your upbringing, or your past mistakes. Those things influence you. They're part of your current information structure, but they don't define all possible future configurations. You can learn, you can grow, you can change. Because you're not a thing, you're a process. Your information processing itself, and processes can evolve. But with this freedom comes responsibility. If you're actively shaping your own information patterns through your choices, then you're responsible for who you become. Not completely. There are constraints, limits, things beyond your control. But within those limits, you have agency. You have the ability to choose which thoughts to think, which habits to cultivate, which information to expose yourself to. And in a world where information is increasingly abundant and accessible, your choices about what information to consume, what patterns to reinforce, what beliefs to adopt, these choices literally shape who you are at the deepest level. You are what you attend to. You become the information you process. So choose carefully. Let me take you somewhere even stranger now. Because if information is fundamental, we need to talk about what happens at the boundary between what we know and what we don't know. And that boundary is where things get truly bizarre. There's a famous thought experiment called Laplace's demon. The idea is this. Imagine a being that knows the position and momentum of every particle in the universe at one moment, and that understands all the laws of physics perfectly. This demon could, in principle, calculate the entire future and past of the universe from that information. The future would be deterministic, completely predictable, already decided. But quantum mechanics destroyed this idea. Heisenberg's uncertainty principle says you cannot know both position and momentum precisely. And quantum randomness means that even with perfect information about the present, the future isn't determined, it's probabilistic. Multiple futures are possible, weighted by probability. But if the block universe is real, then your entire life, every choice you'll ever make, every thought you'll ever think already exists as information in the structure of space-time. You're not creating the future. You're discovering it, experiencing a path through information space that already exists. Here's another mind-bender. What if the universe has a finite information content? We talked about the Bekenstein bound earlier. If there's a maximum amount of information the universe can contain, then there are only a finite number of possible states the universe can be in. It's a huge number, incomprehensibly vast, but finite. If you wait long enough, far longer than the current age of the universe will eventually cycle through all possible states and return to states it's been in before. This is called the Poincare recurrence theorem. Given infinite time and finite states, everything must eventually repeat. Unless, what if information can escape the universe? This is where black holes come back into play. Remember Hawking radiation? Black holes slowly evaporate, radiating away their mass energy. But what happens to the information that fell into them? For decades, physicists thought information might be destroyed in black holes, which would violate quantum mechanics. But recent work suggests that information is preserved, encoded in subtle correlations in the Hawking radiation. The information that fell in doesn't disappear. It gets scrambled and radiated back out in a form that's incredibly difficult to decode, but it's still there. In 2016, Stephen Hawking, along with Malcolm Perry and Andrew Strominger, proposed that information is stored in soft hair on the black hole's event horizon quantum states that don't cost energy to create. This would solve the information paradox. Information is never destroyed, just transformed into increasingly inaccessible forms. But here's the wild implication. If information is conserved even through black hole evaporation, if it cannot be destroyed under any circumstances, then all the information that has ever existed still exists somewhere, somehow. The information that made up every person who ever lived, every thought that was ever thought, every moment that ever occurred, all still out there, encoded in the quantum state of the universe. You are immortal, in a sense, not as a conscious being, but as information. The pattern that is you will persist, scattered and scrambled, but never truly gone. You cannot be erased from the universe. You can only be transformed. And if information is conserved, that raises a profound question. Where did all the information in the universe come from in the first place? Did it exist before the Big Bang? Is there a conservation law that says the total information content of reality never changes, only reorganizes? Some physicists think the total information content of the universe might be zero. Positive information in matter and energy is balanced by negative information in the structure of space-time. Creation isn't the creation of new information. It's the separation of zero into positive and negative, like splitting zero into +1 and -1. If that's true, then everything, the entire universe, all of reality, could emerge from nothing without violating any conservation laws. Not nothing in the sense of a void, but nothing in the sense of zero total information. Am I saying we're definitely in a simulation? No. What I'm saying is that the distinction between real and simulated might not be meaningful. If information is fundamental, if mathematics is fundamental, then there's no difference between a universe made of matter and a universe made of computation. They're the same thing. We might be in a simulation. We might not be. But either way, we're made of information, subject to information theoretic constraints, experiencing a reality that emerges from information processing. Whether there's a simulator or not doesn't change your experience. It doesn't change your consciousness. It doesn't change the validity of your thoughts and feelings and choices. You're still real, in the only sense that real can mean for an information structure. You exist. You process information. You have effects on the world around you. The question isn't whether you're in a simulation. The question is what you're going to do with the information that makes you who you are. All right, we're approaching the end of this journey, and I want to bring everything together into something you can actually use. Because understanding that matter is frozen information isn't just an abstract intellectual exercise. It has real implications for how you live your life. First, let's talk about entropy. Remember, entropy is a measure of disorder, or more accurately, a measure of how much information you don't have about a system. The second law of thermodynamics says that entropy always increases in a closed system. Things fall apart. Order becomes disorder. Structure decays into chaos. This applies to your life too. Your room becomes messy unless you actively clean it. Your body ages unless you actively maintain it. Your relationships decay unless you actively nurture them. Everything trends toward disorder. But here's the key. You are not a closed system. You take in energy from food, from sunlight, indirectly, from your environment, and you use that energy to maintain order, to reduce your local entropy by increasing entropy elsewhere. You are a temporary pocket of order in a universe trending toward disorder. Life is fundamentally about fighting entropy. Every living thing is an information structure that maintains itself against the tide of disorder by consuming energy and exporting entropy to its environment. You stay organized by making your environment more disorganized. But entropy isn't just about physical disorder. It's about information. High entropy means high uncertainty, low information. Low entropy means high certainty, high information. When you learn something new, you're reducing your entropy about the world. When you forget something, your entropy increases. Your life, in a sense, is a process of accumulating information and using it to create more order, more structure, more complexity. And when you die, that information disperses your entropy increases, and the order you maintained collapses back into disorder. But before that happens, you have time, you have energy, you have the ability to create, to organize, to reduce entropy in your corner of the universe. What will you do with it? Second implication: if you're made of information, then your value isn't in your physical substance. It's in your patterns, your experiences, your knowledge, your relationships. These are all information structures that you've built over time. And unlike matter, information can be shared without being lost. When you teach someone something, you're copying information from your mind to theirs. Both of you now have it. When you create something, art, writing, music, code, you're externalizing information from your mind into a form that can persist beyond you. When you love someone, you're creating information patterns in their mind and heart that represent your relationship. Your legacy isn't your body or your possessions. It's the information you leave behind in the minds of others, in the things you created, in the impacts you had on the world. That information will continue to exist and evolve long after your physical form has dissolved. Third implication: if consciousness is information integration, then the quality of your conscious experience depends on how well you integrate information. This means paying attention, being present, connecting disparate pieces of knowledge into coherent wholes. Meditation, in this light, is a practice of optimizing your information processing. By reducing mental noise and focusing attention, you increase the signal-to-noise ratio of your consciousness. You experience reality more clearly because you're processing information more efficiently. Creativity is also about information integration, connecting ideas that aren't usually connected, finding patterns that others miss, generating new information structures from existing ones. The most creative people are those who can integrate diverse sources of information into novel configurations. And wisdom? Wisdom is optimized information structure. It's having models of reality that are accurate, useful, and efficiently organized. Wise people aren't necessarily those who know the most facts. They're those who have organized their knowledge in ways that generate good decisions. Fourth implication: if the universe is computing itself, then you're part of that computation. Your thoughts, your choices, your actions, they're all computational operations that affect the larger information structure of reality. This means you matter, not in a cosmic universe revolves around you sense, but in the sense that you're a genuinely novel configuration of information that has never existed before and will never exist again. Your particular perspective, your unique integration of information, your specific pattern of consciousness, it's unprecedented and irreplaceable. And because you're part of the universal computation, you have a role to play. You're processing information that no one else can process in quite the same way. You're generating outputs, thoughts, creations, relationships that affect other parts of the system. You're entangled with the rest of reality in ways that matter. This should be both humbling and empowering. Humbling because you're just one small pattern in an incomprehensibly vast information structure. Empowering because you're an essential part of that structure, without which it would be incomplete. The universe needed you to exist. Not in a teleological sense, it didn't plan for you, but in an informational sense. You're a configuration that can only arise in this particular universe, with these particular laws of physics and this particular history. You're a product of everything that came before you, and you're a contributor to everything that comes after. So what are you going to do with that? How will you use your limited time and energy to process information, to create order, to reduce entropy, to integrate consciousness? These aren't rhetorical questions. They're the most important questions you can ask. Because if matter is frozen information, and if you're a temporary thaw in that frozen state, then the way you flow, the way you move, the patterns you create while you're liquid, that's what defines you. You are information in motion. Make your motion meaningful. We've covered a lot of ground in the last 3.5 hours. Let me bring it all together into a final synthesis, a unified picture of what it means to live in a universe where matter is frozen information. At the deepest level, reality is mathematical structure patterns of information that exist as abstract Platonic forms. These patterns don't exist in anything. They simply exist as logical possibilities. Among all possible mathematical structures, some are complex enough to support self-aware substructures consciousness. You are one of those self-aware substructures. You're a pattern of information that has become complex enough to model itself and the world around it. Your consciousness is what information integration feels like from the inside. The universe you experience, three-dimensional space, flowing time. Solid matter emerges from information being processed according to mathematical rules we call the laws of physics. Space and time aren't fundamental. They're useful descriptions of how information is organized and how it transforms. What you call matter atoms, particles, stuff, is information in stable configurations. The solidity you feel is electromagnetic forces, which are really information about field states. The persistence of objects over time is information being preserved and propagated through successive moments. At the quantum level, information exists in superpositions until measurement forces it to commit to definite values. This isn't because particles are indecisive. It's because the information about their state genuinely doesn't exist until it's measured. Reality is fundamentally participatory. Observation doesn't reveal information that was already there. It creates information that didn't exist before. Quantum entanglement means that information can be shared between particles instantaneously, regardless of distance. This suggests that space itself might be emergent from quantum information, that distance is really just a measure of how much information two systems share. Black holes are regions where information gets compressed to maximum density at the event horizon. Hawking radiation suggests that information is conserved even through black hole evaporation, but it gets scrambled into nearly inaccessible forms. Nothing is ever truly lost. The holographic principle tells us that the information in a volume of space is encoded on its boundary. Three-dimensional reality might be a projection from a two-dimensional information structure, like a hologram. Depth might be an illusion, useful for organizing information, but not fundamental. Life is information that replicates. DNA is a four-letter code that builds organisms capable of making more DNA. Evolution is an information optimization process, finding configurations that survive and reproduce more effectively. You're not built by DNA. You are DNA's way of persisting. Consciousness is information that integrates itself. Your mind is billions of neurons processing information and binding it into unified experience. Every thought is information transforming. Every memory is information stored in neural patterns. Every emotion is information about internal states. Culture is information that spreads from mind to mind. Languages, beliefs, knowledge, traditions, all are patterns that replicate and evolve. You're not just biological information. You're also cultural information, a hybrid structure spanning genes and memes. The universe as a whole might be a quantum computer, processing its own state according to the laws of physics. The Big Bang was initialization. The expansion of the universe is the computation running. Heat-death is the final state when all free energy is exhausted and no more information processing can occur. But even in heat-death, the information remains. Just maximally scrambled, inaccessible, unable to support complexity. The total information content of the universe is conserved, just increasingly spread out and useless. Time might not be fundamental. It might emerge from entropy, from information becoming scrambled and inaccessible. The arrow of time points in the direction of increasing disorder, but at the deepest level, the laws of physics are time-symmetric. Past and future might be equally real, with consciousness just moving through a static information structure. The multiverse might contain all possible mathematical structures, all possible configurations of information. We exist in this particular structure because we couldn't exist in ones that don't support life. The apparent fine-tuning of physical constants isn't miraculous. It's selection bias. We observe a universe we can survive in. Free will might be the experience of navigating possibility space, of choosing which branch of the quantum multiverse to experience. Or it might be an illusion, with all choices already encoded in the information structure of spacetime. Either way, the experience feels real, and that's what matters. Meaning isn't given from outside. It's created from within. You're a pattern of information that has the remarkable property of caring about things, of valuing certain states over others. That capacity to care, to prefer, to choose, that's the source of all meaning. Your life is a computational process. You're taking inputs from the world, processing them through your neural networks, generating outputs that affect yourself and others. The quality of your computation, how well you process information, how wisely you choose, how deeply you connect, that's what determines the quality of your life. You're the universe experiencing itself. You're information that has become aware of being information. You're a temporary eddy in the flow of cosmic computation. A brief moment when disorder organized itself into something that could wonder, think, feel, choose. Make it count. Process your information wisely. Integrate your experiences deeply. Create order where you can. Reduce entropy in your corner of reality. Love deeply, because love is information binding between souls. Learn continuously, because knowledge is power over uncertainty. Create beauty, because beauty is information that resonates with human consciousness. You're made of the same stuff as stars, not atoms, but information. The same information that organized itself into galaxies has organized itself into you. You're a way for the cosmos to know itself. And maybe, just maybe, that's enough. Maybe being information that cares, information that strives, information that loves, maybe that's the whole point. Not to last forever, but to matter while you're here. Not to know everything, but to embrace the mystery. Not to be perfect, but to be real. You are frozen information, temporarily melted into consciousness. Flow beautifully while you can. Thank you for taking this journey with me. If this changed how you see reality, if it made you wonder, question, marvel, then hit that like button and subscribe. Share this with someone who needs their mind blown. And remember, you're not just watching information, you are information, watching itself. Until next time, keep processing, keep integrating, keep being the extraordinary pattern of consciousness that you are. The universe is lucky to have you.